to stage one. Today, we're going to hear from a number of Parachain teams, implementers, and a few community members discussing their vision for Polkadot and what they've been working on over the last couple of years. The first talk here on track one is a particularly important one, as the first parachains we're going to see launch on Kusama and Polkadot are special and known as common good parachains. The very first of these is called Statement, which is a parachain for reserve-backed assets. What makes something a common good for Polkadot? How does it earn this distinction? What does that mean? In short, a common good chain is granted its slot via governance forever rather than competing in regular parachain auctions because it's considered a permanent piece of infrastructure that should be available to anyone using Polkadot forever, like bridges and roads in a city. Joe Petrowski, technical integrations lead at Web3 Foundation, is about to join me to discuss these concepts in depth and show us what the first common goods chains on Polkadot will do. Welcome back to Polkadot Decoded, Joe.
Hey, thanks for having me. It's actually my first time presenting here. Oh, I guess I did yesterday, sorry. So yeah, back.
Take it away.
All right, so yeah, as Peter said, I'm Joe Petrowski. I work at the Web3 Foundation and I lead technical integrations. So working with like custodians and wallets and validators, and as well now parachains. I'm working on what's probably going to be the first common good parachain called Statements. And I'm going to talk a little bit about the background of what common good parachains are and end a little bit with specifics about Statements. So first of all, before we even get into parachains, just talking about like what common goods mean, because we often think of Polkadot as not just a community, but a community of communities. And common goods play an important role in pluralistic communities when you have a lot of diversity of members and they don't always have the same interests, and they may not even know each other. And of course, like with blockchain, one of the things we fundamentally want to do is let people who don't know each other interact without having to trust each other so much. And so when you have a large society with a lot of people in it, or not just people, but entities as well, there's a lot of public and private motivation. So people have some kind of concept of what it would mean for themselves or their friends or family to be better off. But they also have this idea of like a larger societal vision. So that might be like liberal democracy or something like this, but usually there are some kind of values of the larger society that they feel aligned with. And so that's where common goods come in, where you have some components of the society that are maybe funded by everybody in order to benefit like the overall vision, even if they don't directly benefit yourself or your direct community. And in fact, a lot of times common goods don't actually serve everybody's interest. So if you take a library, for example, you could have somebody in a city who owns a bookstore, and a library might actually not be good for their business. It might actually hurt their business because you have like free books available to everybody. But the society as a whole could agree that this information should be publicly available, and that there should be low barriers for people to be able to access this information, and they choose to fund this library anyway. And a lot of functions in society, whether they're public or private, are actually held to standards that don't reflect like a rational economic actor. So like an example of a public one would be a judge. Maybe a judge is presiding over a trial where their neighbor is the defendant, and their neighbor has a really bad garage band or something, and they're really annoying, and the judge might personally want to find this person guilty to kind of punish them for being an annoying neighbor, but they're expected to kind of rule according to the law and according to the actual case in court, and not their own personal benefits in the outcome. And likewise, like in the private sector, something like a journalist might have a very strong opinion on the outcome of an election and have their own candidates that they prefer, but they're still expected to cover and report on this election in line with some kind of like journalistic standards. So we have this free rider problem, and in Polkadot specifically, it has to do with auctions not allocating stake in an efficient way. So we have some parachains that could benefit the entire network, maybe not every participant, but the overall network, and they will even benefit participants who didn't contribute. So if you imagine some of these parachains actually going off in an auction, then there would be contributors to the auction who didn't, or people who didn't contribute to the auction who actually benefit from this parachain's existence. And usually a lot of people will actually not want to cooperate. Like, so if you participated and backed some parachain in an auction and you found out that I didn't back it, but I still get to use all the benefits of this parachain, you might not want to cooperate with me because you feel like, well, how come I get to use this thing for free when you had to use some of your resources to actually help this get a slot in the network? So when we think about common goods, we're usually thinking about excludability and rivalrousness. So a non-excludable good means that it's not practical to prevent access to it. So it doesn't mean impossible, but if you think of like an outdoor sporting event, like the New York City Marathon, you could, the organizers could build like a tunnel that they make everybody run 40 kilometers through or something. It would be like food in a supermarket. Like if I buy something off the shelf, then well, you can't buy it. And parachains, I kind of debated over semi-excludable and semi-rivalrous, or just completely non-excludable, non-rivalrous. They could be somewhat excludable. They could say, well, like, hey, this user or this other project didn't contribute to my auction, so I'm not going to accept cross-chain messages from them. But of course, you have this kind of like civil problem in blockchain that the user could kind of say like, well, I'll just send a cross-chain message to this other parachain and then have that parachain send a cross-chain message to you. And I'll kind of like clear my messages through that. So it's semi-excludable, but I would say even closer to like non-excludable, where it's just really impractical to not let certain people access a parachain. And likewise with rivalrous, like, yes, there are transaction fees and block limits, and some issues with overcrowding in blockchain use. But generally, like, everybody kind of has access to these blockchains. So a nice little old cartoon that I found that's particularly relevant. People who don't want to cooperate when they think that somebody else is getting something for free that they have to pay for or that they have the rights to. Yeah, so if we kind of look at like a user decision matrix in a parachain slot auction, you could say that whether or not a parachain wins a slot is probably not going to be determined by a single user. So we kind of look at these two cases where the parachain is going to win the slot either way, or it's not going to win a slot, and this user has to decide if they're going to contribute. And of course, they don't know ahead of time if it's going to win the slot or not. And if the user contributes, then they feel that they've paid for others, and they're not really willing to cooperate for the other people who didn't contribute to this parachain. And if they don't contribute, then they're kind of in the opposite camp. They get the benefit from the ability of this parachain, kind of like on the backs of other people who actually contributed to it. And if the parachain doesn't win the slot, if the user contributes, it's not really a huge problem. I mean, they get their tokens back. And if you're not really familiar with how all this auction stuff works, then you should definitely check out Sean's presentation from yesterday. And I think we have like a few other presentations about this topic. And if the user doesn't contribute and it doesn't win a slot, well, to the user, it might not matter. They're going to get to use their resources elsewhere. But this is actually not really optimal from an economic point of view, because this user actually thought this parachain was valuable and wanted to use whatever kind of service that it was providing. So you have a case where like the user is maybe using their funds on something that they consider like the second best choice, and not actually the thing with the most utility to them. So in an auction, it's kind of meant to distribute the slots to however the network deems the most valuable. If you're familiar with the auctions, the DOT or KSM just gets locked up and returned. So it's not really like a cost, but it's just some means, like an objective numerical means of assessing the value of a slot. And these slots are limited. They're kind of like cores on a CPU that can process parachain. And the candle auction mechanism is intended to make teams bid their fair valuation of a slot up front, and not try to like underbid or snipe it at the very end. But we have this problem like a referendum. So this is not just the council or technical committee or anything. We need a full on-chain referendum where all the stakeholders get to vote, and can decide that a certain chain will become a common good chain and actually not have to go through an auction, but get to take one of these parachain slots. And some guiding principles. I don't think these are set in stone. They're just kind of like principles of the overarching idea of what common goods should be. So number one, the chain should use dot or KSM as its native token. Ether token on the other side, and the bridge could introduce its own kind of like third bridge token and kind of like charge fees in this or something. But it's kind of just like this arbitrary capture, like extra complexity. It's not really needed. So it would just make more sense for that chain to use either like dot or like Ether as its native token to actually handle like fees and scheduling and prioritization and whatnot. So yeah, I like generally these chains should be using the relay chain's native token as its parachain's native token. And I'll talk a little bit at the end about like some of the changes we made to actually accommodate this. The governance should be delegated to the relay chain. So the relay chain kind of decides to give the parachain the slot, and the relay chain still gets like further decision-making power in it. So it's not like the relay chain will just give a parachain slot to some team and then they can do whatever they please with it. Things like runtime upgrades and like major decisions on that chain would also be going through the relay chain. And of course, should be seemingly obvious, like they have to make a case as part of their governance proposal of why this would actually benefit the entire network. So going to dive a little bit into the technical weeds about like why, like I kind of said a few minutes ago that parachain slots are limited. They're kind of like these physical cores on a CPU, except in another way, they're also virtual. And so why would we give some of these very limited resources to something instead of making it go through an auction mechanism? So generally speaking, executing logic in the parachain is a lot more efficient than executing it in the relay chain. So in every block, like in the relay chain, every validator in the network has to validate every single transaction in the relay chain block. Whereas Rob and Jeff talked about this a bit yesterday. On parachains, they actually split up into subsets. So if you have 1,000 validators in the network and you have 100 parachains, you actually have 10 validators per parachain. And that's just kind of like what makes them parallel chains, is that each parachain, all 100 of them are just being validated in parallel. And the validators will attest that their validation is good. Other people like the fishermen and collators from the chain can actually check this and make sure that the validators are actually proposing good blocks, that they're available, that they're valid. And so we can kind of like offload and distribute a lot of this work by putting logic into parachains. So in this little example diagram, I have like a relay chain block on the left here where it's updating a couple parachains that maybe won slots and auctions, and then it has like balance transfers and staking rewards and processing a council election inside of this block. And you have all 1,000 validators of the system validating all of these transactions. Whereas if you split them up into parachains, like a balances parachain and a staking parachain and a governance parachain, then you can have just 10 validators processing this whole batch of balance transfers, and then 10 other validators processing all of the staking stuff. So like processing staking rewards and letting people nominate and computing a new validator election. And then you could have another parachain with governance, so like electing council members, fast tracking referenda, and letting all the governance activity take place on the parachain, each of these validated by only 10 validators instead of all 1,000. And then these just get grouped into the relay chain as part of the overarching like updating parachains inherent. So it's not like there's strictly some limited number of parachain slots, like there's just a fixed number, 100, it can never be any more than that. Actually, by moving a lot of these transactions out of the relay chain and into parachains, it opens up all of this computation space. So where you previously had 1,000 validators executing all of these transactions, now you just have 10 doing it. And so those other 990 are free to do other things. And so if we move a lot of this logic off of the relay chain and into parachains, then rather than having 100 parachain slots, we could maybe have 150 or something like this. And so it actually makes a lot more room for parachains to be allocated via auction. So we kind of break common good parachains that we want to allocate these slots into two categories. The first one is called system level chains, and this is unopinionated core functionality. So this is really just like the core functionality that we need to make the relay chain function. And I call this unopinionated because it's already there. So like the relay chain already has balances in it. It already has governance. It already has staking. All of this stuff is there. And so just by like having the runtime upgrades during the launch process that got us to the state where all of this stuff is in the relay chain, the network overall agrees that this stuff should be in the Polkadot network. And when we move it into parachains, we're not really, adding anything new. We're just simply moving it from one place to another and optimizing the relay chain so that it can process more parachains. These should generally be pretty uncontroversial. I mean, everybody's kind of agreed that this stuff belongs as part of the Polkadot network. We're just kind of moving it around a little bit. The second part, and the much more interesting one, is the public utility chains. And this is where it gets a little bit opinionated. So it's functionality that's not really core to the relay chain, but logic that shouldn't be duplicated. So if you look at something like, you could have a smart contract chain that uses DOT or KSM as its gas metering token, an assets chain, which is what statement is, to allow minting fungible and non-fungible assets on chain, and bridges to other networks. So it might not make sense to have 3 bridges to Ethereum, or to have a bunch of different chains implementing their own Ethereum bridge locally. It would make a lot more sense to just have like an Ethereum bridge in one place that everybody can use. And then long-term, these chains have to stay aligned with the relay chain. So this goes back to the governance point about respecting messages from the relay chain, delegating their governance to the relay chain. And I don't know how exactly this is going to evolve long-term, because you can kind of imagine this getting to the point where we have 20 or 30 common good chains, and there could be like a bunch of bridges and system level chains and assets chain and stuff. And there could be just like a huge referenda queue of like updating all of these different chains and managing them. So I don't know how this is going to evolve. So rather than doing like a huge public referendum, you can kind of randomly select 200 members from the community and ask them to vote. And if you get something like 80% of this subset is in favor, then the probability that that like more than 50% of the overall community would be opposed to it is statistically extremely small. So we can use like these combinations of like subcommittees and random sampling and grand oracle committees to make more sophisticated governance, like maintain compatibility and be able to bridge to that chain. So finally, as a concrete example of one of these chains, we're working on this chain statement. And it's an assets parachain. It's going to support fungible and non-fungible tokens, and also the ability to pay transaction fees in these tokens. So there would be actually no need to own DOT or KSM on your accounts, as long as you have some of these tokens that you could pay the transaction fees with, and the collators on the chain would actually accept some of these tokens in exchange for, or not in exchange for, just in lieu of DOT or KSM in order to process transactions. And so we've had to actually make a few changes to substrates and also like the relay chain in Polkadot to make this possible. So one of them is asset teleportation. So we wanted to use the same token DOT or KSM statement as we do on the relay chain. And so we had to make an interface to be able to make the relay chain and the parachain accept these tokens in a cross-chain way as their native assets. Collective dispatch. So this is the idea that the council or the governing body, like the stakeholder assembly on the relay chain, could actually dispatch functions on the parachain. So it could send messages. The parachain doesn't really know about, it doesn't have a concept of like a council or like a collective or democracy or anything. We just kind of tell it, hey, there's this other blockchain out there. It's the Kusama relay chain. They have this thing called a council. And if they send you a message, then you should believe that it's coming from the Kusama council and you should actually act on it appropriately. And collator selection, like how we actually select who the collators for this chain are. And finally, like, yeah, so I maybe did this backwards, statement supporting promise-backed assets. So this would be permissionless. You do have to put that on a deposit in order to create an asset. But if you destroy that asset and take it off chain, you get your deposit back. Fungible, and actually I put eventually non-fungible. I think in the very short term, as in a couple of weeks, then it could also support non-fungible assets. The logic is pretty much done, just need to do some tests and get it in there. And because we're going from like 1,000 values valuing this to just like 10 or whoever's assigned to this parachain, we're able to lower the deposits and fees just because executing logic in the parachain is so much more efficient. So we actually started with 1/10. So things like the dreaded existential deposits and like the deposits or reservations that you make to have like multi-sigs and proxies. These are all going to be 1/10 of what they are on the relay chain. And transaction fees are also going to be 1/10 of what they are on the relay chain. So it'll be quite efficient and practical to use. And we actually hope to get this down to like 1/50th. So hopefully quite a bit smaller and more ergonomic for day-to-day users. And that is it. I think there's a couple minutes for questions.
Awesome. Awesome. Thank you very much, Joe. We do have a couple questions here. First one is, I think, what a lot of people have asked numerous times as we've started sort of educating around what a common good parachain actually should be. A lot of people say, oh, my favorite parachain team is awesome, and they're providing a technology that is good for everyone. So I don't think that they should have to compete in auctions. They should just have a slot forever. Let's make it a common good. What do you say?
Yeah, I mean, I kind of go back to the core principles that we laid out before, that this should really be like for the benefit of the network and not necessarily the project. So there's a lot of stuff out there that's very advanced and useful, and I won't argue with that, but it doesn't mean it's a platform for everybody to build on. So I think actually like an example I could give here would be with statement and the non-fungible assets. So statement doesn't have any kind of like smart contract logic. It just hosts this interface for what an NFT is, and very basic functionality like being able to transfer them. But as far as like the value in, say, like an NFT project would be like building out a community and like space for people to actually use these things. And so without having like the smart contract logic, you can't really do that on statement, but you can build that out on another chain. And so I think this is where like the specialization comes in. You could have something that's like very advanced and useful, but if it's not like just very primitive building blocks for other people to build more complex applications on top of, then I don't think it really fits as a common good. But yeah, it's up to the not me. So.
Yeah, that was the next point, is like governance. Anything can happen through governance, and there's obviously a potential future possibility where a parachain that's had a slot and grown a community and clearly delivered a technology that could be a common good, like the council, the Polkadot governance could potentially like buy out a parachain community to make it a common good, but then that token would basically need to the native token of that parachain would basically need to be swapped out and burned for DOT or KSM if it were to become a common good parachain. So that would have to be like a strong consideration by that parachain community if like an acquisition by the relay chain governance would be something that they would want.
Yeah, a lot of interesting paths that this can go down with on-chain governance.
Yeah. One last question here is actually, I think, quite a good one from Anonymous. Won't relay chain governance become a bit of a bottleneck for various common good chains, assuming there is any meaningful amount of governance work to be done? Wouldn't it be better to partially delegate relevant parts of governance to some maybe common good specific governance structure?
Yeah, I mean, I think that's what I got into a little bit with having a governance parachain that can support some of this more advanced logic or advanced governance systems. And so I think definitely with like a large number of common good chains, it will get, quite clogged with a lot of just even like upgrade maintenance, like upgrading common good chains in order to stay compatible with the relay chain. And so there definitely needs to be some kind of like thought into governance scalability. And I still think that the relay chain stakeholders should have the ultimate say, but definitely the ability to delegate some of the more like day-to-day tasks.
Yeah, and I think part of just like the mental models that a lot of people who are in crypto and blockchain have around governance minimization and a very like laissez-faire model for governance is going to be outdated. I think we're very much governance maximalists in the Polkadot community, and we expect there to be robust engagement by a wide range of stakeholders on these issues. So having the conversation is like something we want to do. We're not as concerned about governance being a bottleneck. We see it more as a opportunity to open up more design space because we actually know we have a process for shipping upgrades and changes that everyone can agree on.
Yeah, we actually see this in the council.
Thank you very much. Oh yeah, go ahead.
We see this in the council already, where there are functions in Polkadot that the stakeholders have access to via referendum that the council does not have access to. And then there are functions that are kind of delegated to the council, like treasury management. But if you look at actually like the origins that are allowed to do that, it says either the council or the stakeholder community. And so the stakeholder community can actually override anything that the council does. And so this is already a form of like delegating responsibility to a smaller group, but the larger group still has the ultimate say if they're not happy with the decisions that the smaller group is making.
Awesome. Thank you so much, Joe. I know this presentation will be reviewed in the future time and time again. It is chock full of important information for the entire Polkadot community. Thank you all very much. We'll be back in a couple minutes with more from the community track.